Hello everyone, in this video we're going to be discussing Unit 1, which is whole numbers. The very first thing you need to know for this unit is rounding and estimation. Before you even get into rounding, you need to memorize this chart, which will show you the place values for numbers. The first step for rounding is to find the place value which you are rounding. Step 2 is to look at the number to the right. If the number to the right is 0 through 4, you keep the number you are rounding the same. If the number to the right is 5 through 9, you add one number to the number you are rounding. Numbers to the left stay the same, numbers to the right turn to zeros. If you're anything like me, steps usually don't help me too much, but visualizations and actually seeing a problem definitely help. So in all of our videos, I'm going to show you examples, and then I'm going to give you opportunities to try some on your own. So let's take a look at an example where we have to round to the nearest hundred. So the number is 32,765. Step 1 is to find the place value which you're rounding. So it says round to the hundreds place. Well, here's the number in the hundreds place, which is a 7. You always look directly to the right. Now, I don't care about any other number behind here. It's the number right beside it. So the number beside it is a 6. So keep in mind, if it's 5 or greater, what's going to happen to this 7 that we're rounding is it's going to bump up to an 8. These numbers stay the same. The 7 will bump up to an 8. Everything else behind it turns to zeros. So again, notice I'm only concentrating on the 7 here. Because the 6 right behind it is a number that's 5 or greater, the 7 bumps up to an 8 and everything else changes to zeros. Let's look at another example. Round to the nearest 10. So where's the tens place? It's here. So we know we have two options here. This 4 is either going to stay a 4 or this 4 is going to bump up to a 5. Students ask me all the time, does this ever round down? No, it does not. It's either going to stay a 4 or it's going to bump up to a 5. And that's all dependent upon the number that's right behind it. The number right behind it is a 1. Since that number behind it is less than 5, this means that the 4 is going to stay the same. And then everything else behind that 4 turns into a 0. So 1,340 is rounding to the nearest 10. This one says round to the nearest 10,000. So let's find the 10,000s place. Here's the thousands, here's the 10,000s. Look at the number directly behind it. I don't care about any of these other numbers, just the number directly behind it. The number directly behind it is a number that's greater than 5. So we know that that 4 that I just circled is going to bump up 1 to a 5, and then everything else is going to change to zeros. Round to the nearest 1,000. So here's the thousands place. I'm going to look at that number directly behind it. The number directly behind it is 5 or greater. So 5, 6, 7, 8, 9, any number behind it that's 5, 6, 7, 8, 9 is going to cause that number that you're rounding to bump up, and then everything else is going to change to zeros. Now this is where things get tricky for a lot of students. So this one says round to the nearest 10, so here's my tens place. Now I'm going to take this 9 behind it. That means that I'm going to bump my 9 up to a 10. This is what really confuses students because you're like, well, where does this 10 go? I don't know what happens. Essentially what's happening when you change a 9 to a 10 when you're rounding, the 0 goes in its place and the 1 from the tens place gets carried over. And then you're going to add these together. So what's going to happen here? This is, again, really tricky. 9 plus 1 would, again, give me 10. So, again, put down your 0 and carry the 1. So anytime you're changing a number to a 10 when you're rounding, you put down the 0 and you carry the 1 over to the next place value. Well, now 6 plus 1 is going to give me 7. Everything else behind it is going to change to zeros. We're going to have practice in just a minute with rounding the number 9. As always, again, I'm going to give you an opportunity to try some on your own. I would strongly encourage you at this point, anytime I say on your own, pause the video, try the problems, and then hit play to check your answers. So, this one says round to the nearest 10,000. Here's the 10,000s place, which is the 6. The number behind it is a 5. That means the 6 is going to bump up to a 7. Everything else is going to change to zeros. Here's the hundreds place, which is a 9. The number behind it is a 5. So here's that example of a 9 bumping up to a 10. So remember what you do here. The 0 gets placed in the 9. The 1 gets carried over to the next place value to the left. So adding those together is going to give me 79,000. Round to the nearest 10. So here's the tens place. There's a number less than 5 behind it. So what I'm going to do is I'm going to keep that 6 the same. And I'm going to change this to a 0. Round to the nearest 10,000. Here's the 10,000s place. The number directly behind it is less than 5. So I'm going to keep that 3 the same. Everything else changes to zeros. Rounds to the tens place is a 5. Right behind it is a number that's greater than 5. So I know that 5 is going to bump up to a 6. Change that to a 0. All right, the next concept that we need to talk about in this unit is operations on whole numbers. So you will have quite a few word problems in this unit. It's important for you to be familiar with this chart, which is going to give you some keywords for addition and going to give you some keywords for subtraction. And then we also have some keywords for multiplication and some keywords for division. If you can pick out these keywords, typically that's going to indicate to you as a student what type of operation that you need to do with those numbers in the problem. So let's look at some examples. The first one said, when shopping for a new computer, William found that he could buy a desktop for $989, but a laptop would be comparable at $1,243. Estimate the difference between the cost of the desktop and the cost of the laptop by rounding each number to the nearest 10. So I'm always a big fan of underlining and boxing and circling and highlighting. Definitely you want to pick out the numbers in the problem first. And then you kind of want to ask yourself, well, what is my key word or what is my key phrase that's going to indicate to me what operation that I'm going to be doing? Well, the key word here is going to be difference. Difference, if you go back to that chart, means subtraction. Now, Ed Ready loves to combine topics. So we just talked about how to round. So it says estimate the difference, which is subtraction, by rounding each number to the nearest 10. So now we combine that rounding with an operation. So let's round each one of these numbers first to the nearest 10. Remember our tens place is here. This 8 is going to bump up because there is a number bigger than 5 behind it. So this is going to be $990. Tens place here is a 4. The number behind it is actually less than 5. So this is going to stay $1,240. The difference again means subtraction. So we're going to do $1,240 minus $990. Now, it pains me as a math instructor to say, but you can use a calculator on all assignments in Ed Ready. So if you're using your calculator here, 1,240 minus 990 is going to give you $250, which is going to be the estimated difference between the two. It says the most expensive hotel in New York costs $439 per night. Would not be a hotel where I would be staying. It says find the cost of a 5-night stay. So this one really doesn't have a key word, but you got to think, you got options here. You're going to do either addition, you're going to do subtraction, you're going to do multiplication, and you're going to do division. Those are your 4 options essentially in math, and you got to decide kind of which one do I need to go with. Now, $439 per night for 5 nights. You have really 2 options here. That means I could add $439 5 times. So 439 plus 439 plus 439 plus 439 plus 439. Anytime though you have repeated addition, so that means something that is repeating over and over and over and over again. You're doing $439 5 times. Repeated addition is the same thing as multiplication. So again, when you have something that's being repeated over and over and over again, that's going to indicate that you're going to be able to multiply those 2 numbers together. So when we do 439 times 5, it is going to cost you $2,195 to stay there for 5 nights. Again, not a hotel that I would be staying. All right, let's look at some more examples. Sally drove 563 miles from Asheville to Wilmington, and then she drove 249 miles back to Charlotte. Find the total number of miles that Sally drove. Again, keyword here, total. Looking at your chart, total means to add. So I'm going to add 563 plus 249, Again, breaks my heart to say, but I would probably use your calculator for this. Add those together, and Sally drove a total of 812 miles. Now, this one is one, hint, hint, nod, nod, make sure you really pay attention to, because I've seen this problem multiple times on tier tests. There will be 340 people on a school trip to Old Salem. Each school bus holds 45 people, and all the buses are going to be filled except for the very last bus. How many school buses will be needed, and how many people will be on the last bus? So there's two questions here. How many buses are going to be needed, and then how many people are going to be on this last bus? Again, you got to stop and ask yourself, am I adding, am I subtracting, am I multiplying and dividing? Most of the time, students can really get addition and subtraction. Adding is when you're finding the total of something. Subtraction is when you're finding the difference between something. Multiplication and division gets a little tricky. Multiplication, I mentioned a while ago, is when you're taking something kind of small and you're repeating it over and over and over and over again. Division, on the other hand, is where you're taking like a large quantity of something and you're separating it into parts. So think about what we're doing here. We're taking 345 people and we're splitting them up amongst all of these buses. This is an example of division. So division, again, remind yourself, take something big, divide it up into parts. So we know we're going to take these 345 people and we're going to divide them into groups of 45 to see how many buses we're going to need. Now, this is again where things get a little bit tricky. When you put this in your calculator, you get 7.55555 going on forever. So I'm going to put a little repeat here. Now, I don't care what this decimal is. It could be 7.1, 7.2, 7.3, 7.8, don't care. Don't think about this as rounding right now. If you have this little fraction of a bus left over, think about how many whole buses are you going to need in order to carry those students. Even if it was 7.1, you wouldn't just need 7 buses, you would need 8 buses in order to account for everybody. Y'all, we can't have a fraction of a bus. It's not going to run. So we're going to need 8 buses in order to carry all of those students. Now, this is the tricky part. How many people are going to be on the last bus? Please don't say 0.5 people, because y'all, we don't have 0.5 people. That isn't how it works. Now, think about what we got here with 7.5. That means that 7 buses are going to be full. Then we got to figure out what this decimal represents here. Well, each bus holds 45 people. So if we take those 7 full buses and we times them by 45, we know how many people altogether we have on those full buses. 7 times 45 gives me 315. Well, how many people are going to be on the last bus? Well, I had 340 people. Now I've got 315 people on the full buses. We basically need to figure out how many people are left over. Think about what that means. Think about what I just said. How many people are left over? That's going to indicate subtraction. So how many people are left over on that last bus? 25 people are going to be on the last bus. The full buses have 45. That's why we did our whole number here times 45. This is full buses, 315. To get that remainder, or how many people that are left over, we did the 340 people that we started with and subtracted the 315. So those are my leftover people. Again, hint, hint, nod, nod. This is a question you might want to go back and replay one more time because you're going to see it again.